Professor Richard Alley of Penn State University investigates how the prehistoric temperature rises affected our weather. He has discovered that this wasn't a time of steady change. Instead, our climate was on an unpredictable and violent roller coaster ride of temperature highs and lows. It all started with a particular alignment of the planets in our solar system. 3 orbital variations, known as Milankovic cycles, alter the amount of heat the Earth absorbs from the Sun. The first Milankovic cycle that Alley considers is obliquity. The Earth doesn't stand straight up relative to the Sun, it tilts. Currently, it leans at an angle of 23.5 degrees. Imagine Alley's head represents Earth, and the lamp is the Sun.
So here's the equator going across my nose and the North Pole sticking out a bald spot on top of my head. If the North Pole was straight up relative to the sun that I'm looking at, I could never get a sunburn on my North Pole bald spot. In fact, the North Pole is tipped over. Right now it's tipped over about 23.5 degrees. And because of that, I can get a sunburn here, and you can have sun in the Arctic in the summer.
But the angle of tilt varies over time.
It nods a little bit. And when you nod farther over, it's more sun at the North Pole, and this is the time when you melt ice. And when it looks up, the sun is at the equator, less at the pole, and this is the time to grow ice.
The angle of obliquity ranges between 22.1 degrees and 24.5 degrees over a cycle lasting 41,000 years. The second Milankovic cycle is eccentricity. This time, a tennis ball signifies Earth, a clementine the Sun, and a hula hoop stands for the outline of Earth's orbit. The Sun's gravity pulls Earth in a nearly circular path. But when we move closer to Jupiter and Saturn, the gravitational forces of these 2 planets stretches our orbit into new shapes.
It goes from being almost round to being quite squashed and back to almost round.
This changes the distance that the Sun's heat travels to reach the Earth. It varies over a cycle that lasts between 90 and 100,000 years. The third Milankovic cycle is precession. Precession is caused by the fact that the Earth is not perfectly round.
The real Earth, when it spins, bulges just a little bit at the equator. It certainly doesn't bulge as much as this one, but that bulge is acted on by the gravity of the sun and the moon, and one of the things that does is causes it to wobble around in a circle.
Just as the spinning top wobbles towards and away from Alley as it winds down, the axis of the Earth wobbles close to and away from the Sun. The toy completes its wobble in seconds, but the Earth takes between 19 and 23,000 years to go through a complete precession. Individually, the orbital variations, obliquity, eccentricity, and precession have a limited impact on Earth's weather. But over a 100,000-year cycle, these 3 oscillations combine to cause major temperature changes, leading to dramatic variations in global ice volumes. Ice ages, caused by changes in the Earth's orbit, have been a regular part of this planet's climate patterns for billions of years. The most recent ended some 20,000 years ago, when the Milankovic cycles coincided to kickstart 10,000 years of global warming.